Progressive Web Apps.
Thank you, David, and thank you everyone for being here. Are you ready for Progressive Web Apps?
I don't hear anything here in the back.
Yeah, you can say it in Spanish. All right. It's gonna take some time. It's gonna work, trust me.
The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive Web Apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go, and all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
It's so nice on a big screen. So, once again, I'm Jojo Brown, and I'm a full-stack teacher in Amsterdam, Brussels, Lisbon, and London, and I'm really happy to be here today. So, before we talk about Progressive Web Apps, how many of you are working with Progressive Web Apps today? Yeah? Okay, so I'm sure you're gonna love this talk. You're gonna learn a lot. So, but before talking about Progressive Web Apps, I want to make a point that which you saw in the video, that the mobile web has kind of been failing us lately. So you can just easily recognize the difference. We'll wait for it a sec. Anyway, you'll easily recognize the difference between a native app and the mobile web. So you can see easily that WhatsApp is branded with its own theme color. Whereas on the mobile web, this is the browser, whether it's Chrome or Firefox, and then you've got the content inside of it. In this case, it's GitHub. So it doesn't really have this immersive experience. However, I wanna ask you a question here. How many developers do you think it takes to fix an iOS app on the store? Yeah? 1? No? 3? No? And the answer is 1 week. That's to voice some of the frustrations that you have with native. But anyway, I'm not going to go that route. It's not like a native versus web talk, but you all know that there are a lot of problems with the native. So, but finally, the web is upgrading, and that's happening through Progressive Web Apps. That's because Progressive Web Apps provide the best of both worlds, the mobile web and native web apps. So, in a nutshell, I want to tell you, like in plain sentence, how it works. So Progressive Web Apps are not magic. If you have any web app right now, you can make it a Progressive Web App. There's nothing you need to install. You have to follow a few steps that I'm going to highlight in a few. And that's it. What's going to happen is that your app will progress into a native feel on devices that support it. And that's because we want to make the experience on the mobile web fast and also reliable. And when I say reliable, if you open a Chrome browser or Firefox browser and go in the metro, and then you click on something and you lose connectivity, you get the dinosaur again. So this is the kind of experiences that are not reliable. But once you make it a Progressive Web App, using Service Worker, you will have a reliable experience because you'll be able to know when the network failed and you can provide an experience for that. So those are the kind of things that you're going to see. And also it's highly engaging. That's because you can send push notifications, which was never possible before. So after doing all of this, I'm sure you guys want to know how it works. So let's start and see how you can add a Progressive Web App, how you can build a Progressive Web App today. So this is, by the way, independent from Angular 2 just yet. At the end, I'm going to show you how Angular 2 makes it easy. So the first part is the web app manifest, and this is actually the easiest one. It's a regular JSON file that you create, and you can put it anywhere in your directory, and then you have to link to it with a manifest, with a link relationship manifest, and in this scenario I called it manifest.json. And here's what you can have inside this file. We're going to go through all of these. So for example, short name, orientation, etc. All right, so let's take a look. Let's see how the short name and the icons affect it. So I have, oops. I lost the signal, yeah. Okay, so with this kind of manifest, if the user goes and add to home screen, this is what they'll get. The video will repeat. So if you add to home screen, once again, the browser will suggest the name which you entered in the short name here, and then the icon. And then once they accept, you will have an icon on the home screen. So that's how easy it is to add a web app manifest. And that's the first part. So it pulls up your icon and it pulls up the short name. The user can change the short name if they want. In this scenario, I'm building a progressive web app that I decided to call Foursquare. And now, you can also specify a full name. So once you have the icon on the desktop, or on the home screen, what happens when the user clicks on it? So when I click on it, you'll have a splash screen that is automatically generated by the browser. And then look at the values. The background color, the blue background color, is coming from the background color. And the theme color that's affecting the status bar is also coming from here. And what else? We are also able to change the orientation. So here I've set it to portrait, you can set it to landscape for games. And once again, you see the icon. So it's like a configuration file that tells the browser more about your application. And it also allows the browser to open it, but while hiding all the browser stuff. So you're not seeing Chrome or Firefox anymore. So let's take a look again to one more thing. So there's also display standalone. And now when the web app opens, this is how it looks like. And if I go and switch apps, you don't see any difference. So it's really styled as a native application, although this is a progressive web app. So this is your browser that's showing it as a native application. So once again, you are able to run the regular code that you know inside of this. So you can also specify a start URL, icons, and you can see how the theme color is affecting the application. So that's a really nice way to make a progressive web app. So that's the first step, actually. And now, the other exciting part is service workers, and I also have a short video for you. And this one is by Udacity.
For too long, users have been left staring at a white screen. For too long, they've been let down by the cruel seas of network connectivity. And for too long, we've been powerless to help. We've been left waiting. But no longer. A new browser feature has arrived. A total game changer. A feature that lets you control the network rather than letting the network control you. Who is this new feature? And what promises does it bring? Introducing the service worker.
So that's just a dramatic introduction, nothing technical. David, if you can hear me, please, you need to plug in the laptop or else we'll go out of business. All right, so service workers is actually the technology that lays the ground up, lays the technical foundation for features such as making your app work offline, sending push notifications, background sync, and also intercepting the network. So let's take a look how it works. So first of all, we're going to register a service worker. And to register a service worker, you know it's not supported on all browsers, so we have to use progressive enhancement. So first of all, we start by checking that if the navigator has support for service worker. So if service worker and navigator. So that's how we make sure it doesn't fail for browsers that don't support it yet. And that's perfectly fine. If you've got service worker support, it will work. If not, nothing bad will happen. And then we need to register the service worker. So navigator.serviceworker.register, and then you give it the path to a JavaScript file. Now, the location of this JavaScript file actually matters a lot. So if you put it inside the scripts folder, it can only affect network requests going out of the scripts folder. I think it's going to happen a lot, so that's fine. And so that's why we always put the service worker most of the time at the root level, because you want to be able to intercept all the requests in your app. And then this is a regular promise, so you can resolve, see if it was successful or if there is an error. And then you're probably wondering what's inside this service worker.js. You can write your own service worker, but it can be tedious. I'd really recommend that you learn it. But for production, it's always better to use tools such as SW Precache. SW Precache is a node module by the Google Chrome team that you can install. So npm install, and you will have the SW Precache binary. And you need to create a configuration file. This is a sample configuration file. What I'm doing here, I'm specifying the files that I want to precache in the static file globs. So what I'm doing here is I'm precaching the font, precaching shell.html, shell.css, shell.javascript. I'm going to talk about these later on. And finally, I'm caching the logo, precaching the logo. And then I just run the command sw-precache, pass in the configuration file, and I will have the service worker code ready. Now, of course, it's going to seem like magic, but once you want to go in production, this is ideal. If you're learning service worker, you can go and see how the fetch event works and all of these steps. So what happens now? If you go to Google Chrome or any other Firefox, open DevTools, you will see that a service worker is registered. Of course, once you refresh the page. So what's going to happen? This is before adding a service worker. You will see that everything is being loaded from the network. But then after adding a service worker, you will see it's being loaded from service worker. So what we have now is we have all of these files available on the device. So what happens, the first time you load the website, you pre-cache those resources. And the next time your users come to your website, they already have it in the cache. So you are able to serve this much faster, reliably. It doesn't really matter if they have connection. It doesn't matter if they're in the subway. You will have all of these resources cached. And then this is only half of the way. Because after rendering this application, so the user needs to interact with it. And to interact with it, we need to be able to do dynamic caching. This is why we use another node module, which is SW Toolbox. So SW Toolbox gives us multiple strategy, like fastest, cache first, and network first. I'm going to illustrate this in the next few slides. So this one is, this is how you can use service worker to get data from the cache rather than getting them from the network. So this is the page, and the green dot is the request. So because the service worker is actually intercepting requests, what happens is when you do a request, the service worker will intercept this request and then forward it to the cache, and then get the data and then return the data to the page. So that's kind of what happened if you got some data from the API, saved it, and then you said to the service worker, okay, let's get it from the cache. So that's one way of doing things. We've also got another way. So this one's slightly more complicated, but it involves the network. So my page has a request, so it gets intercepted by the service worker, and then it goes to the network. And guess what happens? It's going to fail for a lot of reasons. Don't tell me that the network doesn't fail. The network actually fails more often than we think. So again, it could be in the subway, it could be because you have bad connectivity, a lot of reasons. So what happens now? Well, the service worker will get this request again and forward it to the cache, which will then get the data to the page. So how useful is this? If you want to get the freshest data from your API, but for some reason, if you don't have internet, it's fine to get it from the cache. So that's a nice strategy to have. And we've also got the fastest strategy. It's called fastest. So let me show you what happens. Your page has a request, which then gets intercepted by the service worker, and then the service worker will forward two requests at the same time. one towards the network and one from the cache. But obviously the cache is much quicker because it's disk bound, not network bound. So the cache will return the data to the page immediately, but then the request from the network will go and update the cache for the next time you use it. So that's a really nice strategy if you always want to get the quickest response from the cache while keeping your cache up to date. So which one should you use? Well, for every different route, you're going to use a different strategy. So let me show you how you code it. But before that, do you know what Li-Fi is? So that's when your Wi-Fi says you've got Wi-Fi, but it's lying. And if you're on Li-Fi, you can actually stay looking, you can keep on looking at the white screen for over 1 minute until your device says, okay, you don't have internet. So that's a very frustrating experience. And I'll show you a way to fight Li-Fi later on. So, okay, I was saying, this is how you can specify, for this route, or for this regular expression, I want to use this strategy. So toolbox.fastest, whereas for the data that I'm getting from the API, so if I know I'm going to get a static list of countries from the API, I will use cache first. So that's how you can do it. Okay, another nice thing, if you know that your countries only changes once a day, you can actually cache this to, this is the number of seconds in 1 day. So you can cache it for 1 day. And you can say, I only want to store 10 countries, for example. So what's going to happen, it's always going to read from the cache until the next day. It's going to try to read from the cache and see that the cache is empty because they have been purged, and then it's going to get it from the network. And this is how you can fight Li-Fi. So you can say, I want to get it from the network, but I don't want to wait more than 3 seconds. So this can be 3, 5. So this is really useful to fight Li-Fi. If you want to get the freshest content, but in case it doesn't work, you just don't want to wait 1 minute, you want to wait 5 seconds, for example, and you'll say, I'll use it from the cache. But now you're probably wondering, I want to use both. You kind of have to use both. You want to use SW pre-cache and SW toolbox. So it's actually very easy. On the previous configuration file that we've had for SW pre-cache, you add a runtime caching, and this is where you can provide a URL pattern and a handler. So this is a regular expression, that's why I have a lot of backspaces. And what I'm doing here is I'm saying all the caches will be treated with a cache-first strategy. And now, this is really interesting. Once you have a progressive web app and your users go to this progressive web app, this is what's going to happen. So you can see that the browser automatically asks you, would you like to add this to your home screen? That's a really nice feature to increase engagement. But imagine that the browser is going to ask this for every single website. It can become quite annoying to users. So there must be some criteria behind it. And those are the criteria. First of all, you need to have a web app manifest, or else the browser won't know what name or icon to suggest. And you should also have a registered service worker. Ideally, your app should work offline, but I don't think the browsers are checking for this right now. And you should also serve it over HTTPS. So one thing I didn't tell you is that service workers don't even work on HTTP. And that kind of makes sense because if you're on HTTP, you might have a man-in-the-middle attack, and you don't want to allow attackers to control the network. So that's why. And finally, this is interesting, it won't ask the user the first time. So you have to go into the app the first time, and then wait at least 5 minutes, and then the next time you go into this app, the user will ask you. The browser will ask you. So this is a really nice thing for users, but imagine you're testing, you have to go to Chrome, push an update, go back, take coffee for 5 minutes, and then come back. It can become quite frustrating. So luckily, there's a Chrome flag you can enable, and you can bypass this engagement. So once you enable this flag and restart the browser, it will automatically ask you, would you like to add this to your home screen? All right, and push notifications. So I'm going to answer a question here. How come push notifications can work on the web right now? Because, okay, I do have a progressive web app, and I closed it. So Chrome is not running anymore. How come it's working? So let's take the scenario of Flipkart. So Flipkart's API sent a GCM request to Google to send a push notification. Now this GCM will be forwarded to your device, And now your device will wake up Chrome, and then Chrome is going to wake up your service worker. So because you have service worker, this is why I told you it lays the technical foundation for these kind of features. And there's also background sync, but the reason why I'm not talking about background sync is because it's only available in Chrome right now, whereas those are quite more popular. So if you want to know what is working on which browser, there's a very nice website. Is service worker ready? So I only took a screenshot of the first one. So you can see in Chrome, everything's shipped. In Firefox, it's shipped. What else? Samsung Internet is shipped. In Safari, it's under consideration for the next 5 years, so nobody knows when it's going to work for Safari. And Edge, it's in development, and a few weeks ago or a month ago, they said that they expect it in early 2017. So that's really exciting. So we can all build progressive web apps and expect it to work just soon on the rest of the browsers. All right, so any questions so far? Yeah?
Can you repeat how the push notification works?
Yes, so for push notifications, so let's say Flipkart API sent a GCM request to send a push notification, and now now GCM will wake up your device, and your device is going to wake up Chrome, and then Chrome is going to wake up your registered service worker. So then once your service worker is woken up, you can use the notification API to bring a notification on your home screen. So once again, that's why service workers open up a lot of new possibilities. All right, so now that you've taken your first journey into progressive web apps, let's take a look at some of the progressive web apps best practices. Because the thing is, you can make any app a progressive web app, but we have to follow some kind of best practices. And the first one is app shell. Anyone knows what an app shell is? Yeah? So I'm going to show you the app shell for Facebook. Oops. The thing is, with videos, you have to click here. So this is on a throttled connection, that's why it looks super slow. But you can see that in the first few seconds, there's a minimal UI that has drawn on the screen. And then just the app shell. This is just the header, the sidebar. No content. And you've got the same on Inbox. So if you open Inbox, you will see in the first few seconds, you've got the header, you've got a loading snack bar, and the floating action button. So that's a nice way to tell the user, we've got your request, we're working on it, rather than keeping the user waiting on a white screen for about 5 seconds. And so this is how it works. This is the application shell. It's nothing fancy, it's just the minimal design you can have. And then once the page is loaded, so on the left, the content, once the content has loaded, it will go inside of the app shell. Now, for the concept of app shell to work, they must load fast and they must be cached. Because imagine you go to a website and then it takes 5 seconds to load the app shell. Then there's no point in having an app shell. So how can we cache the app shell? Can someone remember from my previous slides? Yeah, what is it? Service worker pre-cache. So in the pre-cache, if you remember, we pre-cache the shell.html, shell.css, and shell.javascript. So that's how we pre-cache the app shell. So the first time we open the app, and then the next time we're going to have everything in the cache. Now, the interesting question is, how can we make it load fast? Because, and the answer is actually progressive rendering, or optimized rendering. Which means, instead of waiting for 5 seconds on a white screen, you actually start getting progressive rendering. So things will start to load progressively. And unfortunately, almost half of the web is unoptimized rendering. So this is why I'm talking about this here. I'm going to give you a typical HTML file to understand why this problem exists and one scenario of how to fix it, one example of how you can fix it. So I'm just loading a CSS file. I've got a bunch of H1 image and then a JavaScript file. And if we profile this on a throttled connection, you will see that this is the HTML file. This is the image, this is the script, and this is the styles. This is the window-ready event, and in this scenario, this is when the browser starts rendering. So I want to ask you a question. What is the browser waiting for to render? What? It's not the image, because this is the window-ready. The scripts, anything else? So you you can't see it very clearly, but it's also waiting for CSS. So the browser is waiting to get all the CSS, all the JavaScript before it starts rendering. Why is this happening? Because when the browser encounters a JavaScript file, it has to go, it stops rendering, it goes and fetches the JavaScript file, and then once it gets everything, it will continue rendering. And same thing for CSS. So that's why we say that both JavaScript and CSS are blocking rendering. All right, so how can we unblock CSS? I'm going to give you one of the ways, one of the strategies you can follow. First of all, you have to inline the critical CSS. So that's right, we get rid of the link rel, and then we inline CSS in there. And then for the rest of the CSS, we're going to dynamically inject it. Okay, so what do I mean by critical CSS? So this is what I'm talking about. So I want someone to tell me, what is this doing? Well, does it remind you of something I've just talked about? The app shell. So this is rendering the app shell. It's a little bit more simplified, but this is the app shell. I'm just setting the background color, removing the margins, adding a header, and then positioning the logo. So this is why we get the minimal CSS that is needed, and we dynamically inline it. And we inline style it. And then for JavaScript, it's easy. You just add an async attribute, and then when the browser sees this async attribute, it's going to continue rendering while it's loading the scripts. So by doing those two, this is what you're going to get at the end. You've got the inline styles at the beginning, h1 image, and then the script tag with an async. And then inside the scripts, for example, I'm dynamically loading the CSS. And let me show you the results. Over the same throtted connection, we started rendering at 200 milliseconds. So let me show you side by side. So it still takes 5 seconds to load, but now instead of rendering at 2 seconds, we are able to render at 200 milliseconds. We're still loading the same resources, but that's because we're working more with the browser. So that's one of the best practices with progressive web apps. Another thing to consider is once you're on a home screen, this is a privileged space. So users don't really know that this is a progressive web app. They think it's a native app, so they expect your app to behave like a native app. So this is why you should avoid having like a website design with a footer, sidebar, etc. You should have something more like a mobile app. And so after the app shell has loaded, the thing is you don't want to keep your users waiting after the app shell as well. So this is why we talk about the first meaningful paint. So the app shell is not meaningful, you're just painting something on the screen. So after the app shell, you need to paint, for example, the posts, the list of posts that you got, but then still users can't interact with it. So that's why you need to allow the user to interact with this. And what does it mean? So that's why if you're loading a lot of JavaScript, that's why you cannot really have a mobile app user experience. So this is why we should minimize as much as possible how much JavaScript we push. And you can do this using the purple pattern or code splitting or a lot of technologies, a lot of ways. Okay, and one more thing. So I always tell people if we as developers don't have debugging tools, there's no way for us to build progressive web apps. But actually, Chrome has some really nice debugging tools. You can see if the manifest is working without deploying it. And you can also see service workers interact with them, see if they're registered, unregistered, and a lot of other things. And there's also a Chrome extension and a node module called Lighthouse, which gives you a checklist, a dynamic checklist. So it tests your website, makes sure it's working, it's tells you what's working, what's not working, what kind of goals you need to hit. So this is a must if you're working with progressive web apps. And this is a short note that I want to add because I spent like 1 week figuring it out, although it's super easy. So once you have, the manifest file is only loaded when the browser needs it. That's why if you have a website, you're not going to see this theme color from the manifest. So this is something you need to add in your HTML head and say meta theme color and give it the value. So this is just something, so normally you have the theme color in the manifest and you also have it in the head if you want it to affect the website. So everything I talked about is something you can use it right now, and that's really nice. But everything I'm going to talk about from now on is not stable yet or broken. But in my opinion, this is really exciting because this is a sign for the future. So So let's get started with the Angular Mobile Toolkit. And the Angular Mobile Toolkit allows you actually to build progressive web apps much easier. So you can take a look at some of this minimal docs on mobile.angular.io. And it's as easy as adding the -- mobile flag. Anyone try to use this -- mobile flag? Okay, so once you run this is what you're gonna get. But again, I told you it used to be working, now it's broken, but this is kind of a work in progress. This is why I'm giving this talk, to excite you about this kind of technology. So, although you can build progressive web apps by yourself, if you're using Angular 2, once the mobile toolkit is ready, it will make it much easier. So, first of all, you're gonna have a default manifest file. It's called manifest.webapp, but you can rename it or you can keep it the same. So you have some defaults and you can go ahead and change them. That makes it a little bit easier. And you also have an automated build for the app shell, which means you don't have to worry about getting the styles, the ones you want to inline. This is something that Angular, the build tool will do automatically. So it's going to figure out which are the things you need as part of the app shell. So you'll annotate and say, this is part of the app shell, this is not part of the app shell. And then it's going to get all the critical styles and then inline it in the head automatically. And it's going to pre-render the app shell. So how do you annotate it? By using star shell render and star shell no render directives. So when you use star shell render, it means this is part of the app shell, but once the app has loaded, I want to take it out. That's why we have a spinner. And then once the app has loaded, we want to take it out. And for the router outlet, of course, it's not part of the app shell, or else you're going to pre-render the whole app. So that's why we add star shell no render. And finally, we've got service worker, basic service worker support. So all your static assets will be pre-cached, which means recurrent visits are going to be fast, and it's going to work offline. So even though it doesn't work, again, this is not the end. You can expect soon some documents, some documentations, guides, and even tighter service worker integration. And since we talked about Ionic, I added a couple of slides about Ionic. So if you're building Ionic 2 apps, they also provide you with a sample manifest that you can go around and tinker with. And same thing with the service worker. So if you're building Ionic 2 apps, you can just go ahead and uncomment the service worker registration code in your index.html, and then play around with the service worker file, and you basically got progressive web apps. So I've added a couple of resources here. Mobile.angular.io is for the Angular Mobile Toolkit. If you want to see other progressive web apps, you can go to pwa.rocks. And for all the technical documentation, you have the excellent Mozilla Developer Network and excellent Google Web Fundamentals. So everything I talked about today, service workers, web app manifest, you can find it there. Okay, so just on time, I think I've got only 20 seconds. So thank you so much. I really hope you enjoyed this talk. You can follow me on GitHub, and you can even find the slides for this presentation on bit.ly pwa-Barcelona. Thank you.
Wow. Thanks so much. Yeah. Awesome talk.